All right, we're working on Chapter 2, Section 1, Linear Equations. Couple things we need to know up front. First is the addition property of equality. That tells us that if A is equal to B, then A plus C equals B plus C. That's just an algebraic way of saying that if two things are equal, even though they look different, the equal signs says they're exactly the same. So if they are indeed equal, then I can add or subtract anything I want to one side as long as I do it to the other, and it would still remain true. So if I had something like 1 plus 2 equals 3, we can agree that that's true. 1 plus 2 is equal to 3. I can add 1 to both sides, and I end up getting 1 plus 2 is 3, plus 1 is 4, is equal to 4. Alright? So that's all that it's saying whenever it says if A is equal to B, that means they're the same. Then I can add or subtract. Don't forget, I can add or subtract from both sides, and it'll remain true. Alright, the next one is the multiplication property of equality. Property of equality. Alright, and that's going to look a little bit similar. It's going to say if A is equal to B, so if both sides of the equation are identical, which the equation sign says they are, then A times C is equal to B times C. Again, this works for multiplication or division. It doesn't matter which one, as long as we do the same to both sides. An example of that would be if we had something like 4 is equal to 4. Clearly those are the same. I can multiply this side by 2, multiply this side by 2, and I get 8 equals 8. Or I could have, if this side was 4 equals 4, I could have divided by 2 and divided by 2, and I would have got 2 equals 2. So that is true, that is true. Alright. Kind of where we're going with this is we know how to solve for a variable. These are the rules that we're using to do that. Alright, so we've got 4 steps when it comes to solving linear equations in one variable. Number 1 is we're going to simplify each side of the equation using the order of operations. Alright, so if you have like terms, you're going to combine like terms using PEMDAS or the order of operations. Alright, once we've done that, we're going to isolate the variable term. So what it means to isolate the variable term is the variable most of the time will have a coefficient. We need to get all of those on one side of the equation. So if there's one on either side, we're going to combine them. The way we're going to do that is we're going to use the addition property of equality. So basically we're going to add or subtract the constant to one side of the equation. We're going to add or subtract the variable terms to the other side of the equation using the fact that we can do that to both sides and it's still the same, the addition property of equality. Our third step is we're going to isolate the variable, not the variable term, but the variable. So by saying that, basically what we're saying is we're going to get whenever the coefficient is off of it, and we're going to do that by using the multiplication property of equality. Step 4, we're going to check the solution. Alright, we just want to make sure we got the right answer. Alright, so every time we're doing the exact same 4 steps. We're going to simplify each side of the equation using the order of operations, combining like terms, etc. Then we're going to isolate the variable term using the addition property of equality. Step 3 is isolate the variable by using the multiplication property of equality. I left that property there. And number 4, check the solution. So let's do a couple examples. Example A, we'll do 5x minus 3 is equal to 12. I'm going to simplify each side. There's nothing I can combine on either side. I've got they're not like terms. So step 1 is done. Second step is to isolate the variable term. So the variable term is 5x. I need to isolate that. That means I need to get that 3 off of that side. The way I move the 3 is use the addition property of equality. It tells me that I can add or subtract anything from this side of the equation. So because I'm subtracting it in the original, I'm going to add 3. Negative 3 plus 3 is going to cancel out. But if I do it to that side, I have to do it to this side as well. So we said those will cancel out, leaving me with 5x equals 15. So that was the addition property of equality. Step 3 is to isolate the variable term by using the multiplication property of equality. What I'm seeing here is that x has that 5 attached to it. I need to move that to the other side. Right now it's being multiplied. I understand that that's multiplication. So I'm going to do the opposite of multiply, which is divide. Whenever I do to one side, I have to do to the other. And again, the 5's will cancel. 5 divided by 5 is just 1. So I get 1x on this side. 15 divided by 5 is 3. So my solution is 3 as long as it works. So going back up to the top, I'm going to substitute and check the solution, my last step. I'm going to replace x with 3 and see if it works. 5 times 3 is 15, minus 3 equals 12. 15 minus 3 is 12. So that does work. That is our solution. All right. See one maybe a little more complicated looking. Let's do 2/3 x minus 4 is equal to 1/4 x plus 6. What makes this look a little more complicated, it does have a constant, a term without a variable on both sides. What really makes it look a little more complicated is we're having to deal with these fractions. All right? But we've learned how to clear those fractions out. If we don't like them, let's just get rid of them. What I need to do is multiply both sides by the least common denominator of all 4 terms. All right? We need to remember that 4 is a fraction because it's 4 over 1. 6 is a fraction because it's 6 over 1. The common denominator between 3, 1, 4, and 1, the LCD, is equal to 12. So I'm going to multiply both sides by 12. Alright, now I'll multiply 12 times this side as well. So I need to distribute. 12 times 2/3, well 12 times 2 is 24, divided by 3 is 8x. 12 times -4 is -48. 12 times 1/4. 12 times 1 is 12, divided by 4 is 3. And 12 times 6 is plus 72. Alright, so now I have cleared my fractions. Everything is simplified. Now I need to get my variable terms on one side and my constant terms on the other. So I could either subtract 8x from both sides, or I could subtract 3x from both sides. I personally like positive numbers. I'm going to subtract 3x from both sides. Since I'm going that direction, I'm going to add the 48 to both sides to move it to the other side. So those will cancel. Those will cancel. 8x minus 3x is 5x. 72 plus 48 is the same thing as 70 plus 50, so 120. Now I'm going to use that. So I used my addition property of equality there. Now I'm going to use my multiplication property of equality because all I have left is the 5. So I'm going to divide both sides by 5. And x equals 24. Alright. So when I go to check it, 2/3 times 24 minus 4 equals 1/4 times 24 plus 6. So when I go to multiply, the 3 goes into 3 one time, 3 goes into 24 8 times. 2 times 8 is 16 minus 4 equals 4 goes into 4 one time, 4 goes into 24 6 times. 1 times 6 is 6 plus 6. 16 minus 4 is 12. 6 plus 6 is 12. So that does work. That would be our solution. Okay, so when we solve these linear equations by using the steps we've talked about, we're going to get 3 types of equations. We have conditional, which is what most of them will be. Conditional has a finite number of solutions. It could be 1, it could be 2, it could be 3 solutions, but there is a finite number of them that can be counted. It doesn't just keep going. A contradiction. Okay, so a contradiction has no solutions. Nothing will work. And we have identities. An identity has an infinite number of solutions. There's not a number that you can create or say that won't work in an identity. All right, so let's do some examples here. Let's look at our first one. We have 2 times the quantity of 3x plus 2 is equal to 6x plus 4. When I start working this one, I know that I have to distribute the 2 times the 3x, and I get 6x. And I have to multiply the 2 times the positive 2 gives me plus 2. On the other side, I did that one wrong. 2 times 2 is 4. Easy to make mistakes. You always got to double check yourself. Equals, this side we had 6x plus 4. Alright, so immediately when we see that the left side of the equation is exactly the same as the right side, that tells me that there's not a single number I could choose for x that wouldn't work. If I chose 0, 6 times 0 is 0 plus 4 is 4 on the left side. 6 times 0 is 0 plus 4 is 4 on the right side. Every number would work. So that one is an identity. And you know it's an identity as soon as you get the left side of the equation is identical to the right side, you're done. You could solve this all the way down and you would end up getting x equals x. All right, another example. We have 3b plus 2 is equal to b plus 4. So using my steps that we talked about earlier, I'm going to, I can't simplify it. There's no like terms, so I'm going to use my addition property of equality. I'm going to subtract the 2 from both sides, and I'm going to subtract the b from both sides. Get some cancellation there. 3b minus b is 2b, equals 4 minus 2 is 2. Divide both sides by 2 using the multiplication property of equality, and I get b equals 1. That's a finite number of solutions. That is conditional. That is how most of the ones we get will be. So, and you got to make sure you watch the directions. The directions on these probably don't say to solve. They probably say to state whether it's an identity, conditional, or a contradiction. So you got to make sure you watch that closely. It may have you do both. Make sure you're watching that pretty closely. All right, so let's look at one like a plus 3 is equal to a minus 2. So on this one, I can already tell I don't have anything in front of the a, so I'm taking a number and adding 3 to it, and then on one side, and the other side I'm taking that same number and subtracting 2 from it. And there's no number I know of that when I add 3 to it is the same as if I had subtracted 2 from it. But just to make sure, let's go ahead and solve this. Let's just move, we'll add 2 to both sides. That and that. Oop. Got a little ahead of myself there. The first one cancels, and I get a plus 5 equals a. Now I'm going to subtract a from both sides. Those cancel, and those cancel. So I get 5 equals 0. 5 can't equal 0, right? So that is a contradiction. All right, so we've got 3 different types of answers. The equation's either going to be an identity, it's going to be conditional, or it's going to be a contradiction. It's going to be one of those 3. All right, let's talk about absolute values for just a minute. Let's do a little review. So let's say the absolute value of 4, and we'll do the absolute value of -3. So absolute value, the way we define it, it's the distance, absolute value is equal to the distance from 0 on a number line. All right, so I have a number line. It's not a very straight one, but it is a number line. There's 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so it's asking me for the number 4. What's the absolute value of 4? Well, 4 is going to be right here. And whenever I count the distance from 0 to 4, it's going to be 1, 2, 3, 4 places from 0. That means the absolute value of 4 is 4. -3 is going to be right here on the number line. And whenever I count the distance from 0 to -3, I get 1, 2, 3. So it's also 3 units away from 0. So because the number line is distance, we never measure distance in negative miles. If you drive your car from Texas to California, it's going to add those miles to your car. When you drive it back, it's not going to subtract those. It's going to add that many miles again. Same thing applies here. Distance is measured in positive numbers, whether you're going left on the number line or whether you're going to the right on a number line. All right, so let's say, let's throw a letter in here. Let's start getting into these variables. Let's say we have the absolute value of x is equal to 4. This one's a little bit tricky because intuitively I want to say the answer is 4 because we just said the square or the absolute value of 4 is 4. But 4 is not the only thing that could have worked. Because -3, the absolute value of -3 is +3, then that means the absolute value of a negative becomes positive also. So x is going to be equal to 4 or -4. All right? If I plug in, if I go back and plug in, let's check it. If I plug in the absolute value of 4, we've already said that equals 4. And the absolute value of -4 is also equal to 4. All right? So that bit of knowledge is really going to help us whenever it comes to solving linear equations that have absolute values in them. So let's look at one here. And I want to note, this is the same thing as x equals plus or minus 4. All right, I want us to get used to that notation. We need to see that and be able to write it and understand what it's saying. It's just saying that it could be positive or negative. All right, so if I have the absolute value of r plus 7 is equal to 13. Normally my goal here is to use the addition property of equality to move that 7. The problem is that 7 is stuck inside those absolute value brackets along with that r. So what I need to do before I can remove that 7 is remove the absolute value brackets. I'm going to treat r plus 7 as a quantity. So I'm going to take that quantity, the way I remove the absolute value brackets is I'm going to take what's inside them and set it equal to 13. And then I'm going to take the opposite of what's inside and set it equal to 13. I need to do that because we just showed that whenever is in those absolute value brackets, whenever number that ends up being could be positive or negative and still equal 13. So whenever you have to add to 7 to make it a positive 13, or whenever you have to add to 7 to make it a negative 13, either one will work. So on this first one, where I just took what was inside it, r plus 7 equals 13, now I can subtract the 7. I've gotten rid of my absolute value brackets. I'm going to subtract 7 from both sides, get some cancellation. R is equal to 6. Over here, I should have a red flag. I've got a negative outside of a set of parentheses. And anytime I have a negative outside a set of parentheses, I know I need to distribute it to the R and to the 7. So I'm going to end up with negative R minus 7 equals 13. So to solve this, I'm going to add 7 to both sides. I get negative R equals 20. I don't care what negative R is. I care about R. So I need to multiply or divide both sides by negative 1. And I get R equals negative 20. So that's the two solutions. With these, because I did force those, I'm going to have to double check both of them. So let's do the first one. Absolute value, I'm going to replace R with 6. 6 plus 7 equals 13. Add those together, I get the absolute value of 13 equals 13. That is true. That one checks out, so we're good. R equals 6 is a solution. On this other one, I'm going to have negative. Now I'm going to replace R with negative 20. Plus 7 equals 13. Order of operations says I need to do what's inside the parentheses first. Need to be careful there. I jumped ahead a little bit. My apologies. It's the absolute value of negative 20 plus 7 equals 13. I skipped down to the where I dropped the absolute values. Alright, so combine my like terms. Negative 20 plus 7 is negative 13. Then I get 13 is equal to 13. That is true. Therefore, negative 20 works as a solution. Alright, so let's look at one more. Get rid of these. Alright, so let's do the absolute value of 2x minus 3 equals 4x. Okay, so nothing I can simplify. I need to drop my absolute value bars. The way I do that is take what's inside it and set it equal to 4x, and take the opposite of what's inside it and set it equal to 4x. We'll start on this one first. Subtract 2x from both sides. I get negative 3 equals 2x. Use the multiplication property of identity, or equality. And I get negative 3 halves equals, helps if I write what I'm saying, equals x. So that's one solution I'm coming up with. Now I need to push this minus through. I'm going to have to do that every single time. Negative 2x plus 3 equals 4x. So now I'm going to add 2x to both sides. I get 3 equals 6x. Divide both sides by 6. And I get 1/2 equals x. Alright, so now I need to double check both of them. I'm going to go back and replace x with negative 3 halves. So I've got 2 times negative 3 halves minus 3 is equal to 4 times negative 3 halves. 2 times negative 3 is negative 6, divided by 2 is negative 3, minus 3 equals 4 times negative 3 is negative 12, divided by 2 is negative 6. I've got negative 6 equal, the absolute value of negative 6 is equal to negative 6. And as soon as I see that, I've got a problem. That negative sign, the absolute value of anything is always positive. I'm already saying here I've got the absolute value of negative 6 is equal to a negative number. That's not possible. The absolute value of negative 6 is positive 6. That means that this does not work, which means that this does not work. And we're going to call that an extraneous solution. That is spelled E-X-T-R-A-N-E-O-U-S. That is an extraneous solution. Will not work. So let's try the other one. Absolute value of 2 times 1/2 minus 3 equals 4 times 1/2. 2 times 1/2 is just 1 minus 3 equals 4 times 1/2 is 2. So I'm going to have the absolute value of negative 2 is equal to 2, and that is true. The absolute value of negative 2 indeed is 2. So that one works. That means we only have one solution on this one. I meant to highlight and I erased instead. We have one solution on this one, and it is x equals 1/2. The other is an extraneous solution. Okay, so the last part on this section we're going to talk about is literal equations. All right. And literal equations are equations that use letters to represent quantities. Basically what that means, we're going to have multiple variables within one problem, and we're only going to be able to solve for one of them. So, for example, it gives us ax minus c equals 5x. And it wants us to solve for x. That's the important part. We're figuring out which one of these do we need to solve for. Anytime I solve for something, I'm getting it on one side of the equation, everything else on the other. I see that I have two x's in this equation. I have one right here, and then I have one over here. So what I'm going to do is move both of those to one side of the equation, and I'm going to move the c to the other side. All right, so I'm going to subtract 5x from both sides, and I'm going to add c to both sides. Those will cancel. Those will cancel. So on this side, I'm left with ax minus 5x. This side I'm left with is equal to c. All right, so now it kind of looks like we're stuck because we have ax minus 5x, and do we know a trick to get it from 2x's down to 1? Well, we do. We can factor that side, and anytime we factor, we're looking for a GCF. So I've got an x in the first term, and I've got an x in the second term, which means I can factor that out. I'm going to pull out an x, and I'm going to be left with a minus 5 equals c. I need to get rid of the a minus 5 off that left side, so I'm going to divide, because it was being multiplied, both sides by a minus 5. Get cancellation over here, and x equals c divided by a minus 5. I'm just going to give you a hint. If you had written it like this, at that point, that is not right. You have to put the a minus 5 in parentheses. Otherwise, the order of operations will divide a by c before it subtracts 5 from a. All right, so that's our solution. You could have written it this way. I probably would have written it the first way. All right, that wraps up section 2.1, linear equations. You just got to get some practice on these. They're not going to be terribly difficult, but you got to remember those 4 steps. All right, simplify both sides of the equation. Use the addition property of equality to get the x's on one side, everything else, the variables on one side, everything else on the other. Use the multiplication property of equality to get rid of the coefficient, and then double check your answer.